What if the next glass of drinking water did not come from a river, a well, or a bottle, but from the air around you? It sounds impossible until you remember that every breath already carries invisible water. The problem is not whether water exists in the sky. The problem is how to catch it. Today, engineers are building machines that turn air into safe drinking water. More than 2 billion people still lack safely managed drinking water. In many places, the nearest clean water is hours away. Underground aquifers are falling, rivers are shrinking, and droughts are lasting longer. But above all of it, the atmosphere holds a massive moving reservoir. Humans have always tried to steal water from the air. Fog nets capture mist on mountainsides. Dew collectors cool surfaces until vapor becomes liquid. But modern atmospheric water generation takes the idea much further. The simplest version works like an air conditioner with a purpose. Air is pulled in, cooled below its dew point, and water droplets form. Then filters, minerals, and storage systems turn that liquid into drinkable water. This works best in warm, humid places where the air is already heavy with moisture. But deserts change the game. Dry air contains less water, so normal condensation can demand too much energy. That is where special materials become the breakthrough. Some materials act like microscopic sponges for water vapor. One powerful family is called metal organic frameworks, or MOFs. Their internal surface area can be enormous compared with their weight. At night, they absorb moisture from the air. During the day, heat releases the trapped water for collection. Some commercial systems now look almost like solar panels. But instead of producing only electricity, they produce drinking water. Air enters the panel, water vapor is captured, and sunlight powers the cycle. The result is a small water source that does not need pipes or a city grid. This matters most where infrastructure is broken, distant, or too expensive. A school can use it when wells are contaminated. A hospital can use it when trucks cannot arrive. A disaster zone can use it when pipes are destroyed. The most surprising part is that the technology is not trying to replace every river. It is trying to create water exactly where people need it. That changes the economics of water. Instead of moving heavy liquid across long distances, you harvest invisible vapor on site. But this technology has limits. Very dry air means lower output. Cooling-based systems can consume significant electricity. Filters and storage must be maintained, or clean water can become unsafe. So the real race is efficiency. Researchers want more water from less energy, especially in dry climates. New sorbents, hydrogels, and MOFs are being designed to capture vapor faster. Some experiments even use ultrasound to shake water out of the material. The deeper story is not a machine. It is independence. A village with local water becomes less vulnerable to drought, conflict, and failed delivery. A home with its own water source becomes harder to cut off. Islands could reduce bottled water shipments. Refugee camps could gain cleaner emergency supply points. Farms could protect small amounts of high-value water for seedlings and sensors. Military and exploration teams could carry less water into remote zones. This is not magic water. It obeys physics, humidity, temperature, energy, and maintenance. In the wrong climate, the wrong machine can disappoint. In the right use case, it can be life-changing. The future may combine solar power, smart sensors, and advanced materials in one quiet panel. It may know when humidity rises and harvest at the perfect moment. It may store water safely, mineralize IT and send alerts before filters fail. The machine becomes less like an appliance and more like a local water organism. But there are questions we cannot ignore. Who owns the machines? Who repairs them when parts break? Who ensures the water remains safe after months in harsh conditions? A water from air device is only useful when it fits the people around it. Technology alone cannot solve water inequality. But good technology can remove one impossible barrier. It can make the first safe glass possible. The strange truth is that water scarcity is not always about absence. Sometimes it is about access. The atmosphere may be one of the most overlooked water networks on Earth. It is everywhere, moving silently above every border. The glass at the beginning was not a fantasy. It was a question. If clean water can be pulled from empty-looking air, then the map of survival changes. Deserts become testing grounds. Rooftops become wells. Air becomes infrastructure. And the next water revolution may not begin underground. It may already be floating above us.